Hey guys! Okay, so today we are doing Pythagorean identities and double angle formulas in trig proofs. And what do you know about the word proof? The word proof sometimes shows up on IB exams as the word show. And that just means you have to algebraically manipulate only one side and get it to match the other side. So let's do the warm-up, which is basic skills. Prove that the tangent of pi over 4 is equal to the sine of pi over 2. So what are the identities that our formula booklet gives us? Well, it gives us that the identity for tangent of theta is right here, sine of theta over cosine of theta. So I'm going to pick this side to rewrite. So I've got the sine of pi over 4 over the cosine of pi over 4 is equal to the sine of pi over 2. I'm going to try to get this side to match that side, okay? So I've got the sine of pi over 4, which is, rad 2 over 2. And then the cosine of pi over 4 is rad 2 over 2, which equals 1. And then the sine of pi over 2 is what we're trying to get it to match, okay? So we have the sine of pi over 2 is equal to 1. We are good. Okay, so what are we trying to do here? We're just using all the trig stuff that we know, and we are going to write proofs, do shows, algebraically manipulate, okay? So we have other quotient identities that are useful to us, right? So we have the sine of theta over the cosine of theta is equal to the tangent of theta. We have the cosine of theta over the sine of theta is equal to the cotangent of theta. We have 1 over cosine of theta is equal to the secant of theta. And then we have 1 over the sine of theta is equal to the cosecant of theta. In our class, we mainly only focus on these, but these could be useful if you ever get weird stuff. Also, it's just good practice trying to rewrite things. What are the other useful identities that we know? We know that sine squared x plus cosine squared x always equals 1. We can rewrite this to get other versions of things. So cosine squared x can be rewritten as 1 minus sine squared x, and vice versa. You start with the ultimate Pythagorean identity, and you could subtract off that cosine squared x from both sides, and you could get sine squared x is equal to 1 minus cosine squared x. There are so many ways that we can rewrite the identities that are given to us, okay? So let's do an example. So in example 1, we want to show that the sine of theta over 1 plus the cosine of theta plus the cosine of theta over the sine of theta is equal to the cosecant of theta. So I'm going to pick the side that's a hot mess, and I'm going to try to get it to match the nice side. It looks like this is going to be my hot mess. So let's go ahead and zero in on that side of the equal sign, okay? So I've got sine of theta over 1 plus the cosine of theta. Hang on, I'm trying to add it to a fraction with an uncommon denominator. Let's get a common denominator here while we're doing the work, okay? Otherwise, I don't really know too much what's going on. So then I've got the cosine of theta, and let's multiply him by 1 plus the cosine of theta. I'm going to scooch my line over a bit. Okay, he is over the sine of theta, and then I'm getting a common denominator, so he's going to be over 1 plus the cosine of theta. Okay, so now I'm going to distribute, and I'm going to get sine squared theta over, I'm not going to distribute the denominator because I have found in my work that things often cancel. So then now I'm going to distribute here. I get cosine of theta plus cosine squared theta all over sine theta times 1 plus the cosine of theta. Ooh, okay, so now I can combine this all into one nice numerator because I have a common denominator. Sweet. So I've got sine squared theta plus cosine squared theta. Ooh, ding, 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 ding. That should be setting off a nice little alarm bell in your head. What do you think the alarm bell going off in my head was? Other than it's time to go get some food. This equals 1. Yay! So I have cosine of theta plus 1 all over sine theta times 1 plus cosine of theta. Yay! These cancel, and I'm left with 1 over the sine of theta, which is equal to the cosecant of theta, which is equal to the cosecant of theta, which I was trying to prove in the first place. Hallelujah. Let's go to number 2. So in number 2, it looks like it might be a little sketchy here, but I think we could definitely do that. All right, so tangent of x plus the cotangent of x is equal to the secant of x times the cosecant of x. They both look kind of equally gross, but I do know that I can rewrite these as quotient identities, quotient of two functions, so I'm going to do that. I'm going to do, let's do sine. Usually, like, a nice little thing is if you can change everything into sines and cosines, sometimes it helps you get started if you don't know where to start. So sine over cosine plus cosine over sine. And it looks like I'm going to definitely have to get a common denominator here, so I'm going to scooch this guy over. Hang on. Sorry if you're writing in pen. The common denominator here, I'm going to multiply the cosine of x by the sine of x over the sine of x. I'm going to multiply this guy by the cosine of x over the cosine of x. So now I would get sine squared x plus cosine squared x. Hallelujah! I know what that's going to happen. Cosine of x times the sine of x is my common denominator. So I've got secant x, cosecant of x. So then this becomes a 1. And I have 1 over the cosine of x times the sine of x. I'm trying to make it equal the secant of x times the cosecant of x. Well, I can rewrite this as 1 over the cosine of x times 1 over the sine of x. And those can be rewritten as the secant of x. Too many x's times the cosecant of x. And we're done there. And then last but not least, let's do this last one here. So I have sine x times cosine squared x. Careful, I feel like kids see the sine x and the cosine squared x and they're like, oh yeah, that just equals 1. No, they're being multiplied. Careful, right? Minus the sine of x equals negative sine cubed x. Okay, so I see a sine of x, the sine of x as a common factor between these two terms here. So I'm going to factor it out and see if that helps me out, okay? So I've got the sine of x, and then I've got cosine squared x minus 1 is equal to negative, I'm trying to get it to match sine cubed x, negative sine cubed x. All right, so, oh, this is great. What's cosine squared x minus 1? Well, I think I solved for that guy up here, and 1 minus cosine squared x is equal to a positive sine squared x. So it looks like if I wanted to get a cosine squared x minus 1, I would have to start with the ultimate Pythagorean identity and see if I can manipulate it to match what I want here. So I have cosine of x minus 1, so I need to move that 1 over. And I would get sine squared x plus cosine squared x minus 1 equals 0. And so I'm going to move that sine squared x over minus sine squared x over. And now I have negative sine squared x is equal to cosine squared x minus 1. Oh, cool. So I can just like sub this guy in right there. So now I've got sine of x times negative sine squared x is equal to negative sine cubed x. Oh, sweet. Yes, that is 100% true. I'm going to multiply these together, move the negative out front, and I have shown what I wanted to show.